Alright, students, we'll be reviewing class exercise 2 right now. Maybe before we review class exercise 2, it will be good for you to know that you need to first know how to draw NO2 from your lecture notes. Yep, this was given as one of the lecture exercises. Yep, so you will need to try to draw it out before you attempt this particular class exercise. If not, all the effort will go down the drain because I think you need to have a basic understanding of how I can draw NO2 before you move on to do this. Yeah, because if not, you might start from scratch and it might not go very well. Because if you start from scratch, then you will try to be, arranging the electrons in a way that you might not want to. Just know that this exercise is a build up from the different question parts. Perhaps maybe part B is independent, but A, C, and D, they are built up from one another. Yeah, especially from C to D. Okay, yep. So maybe before we begin, I will first illustrate how to draw NO2. So NO2 is a very classic example that is often asked in A-level exams. I mean, because most of the students will draw it wrongly if they attempt it the first time. But of course, when you go for your A-level exam, you are already very familiar with it. So you probably wouldn't get it wrong. Yeah, so what's going to happen is that the first thing you might want to do before you draw NO2, right, is first to look at nitrogen and decides how many valence electrons there are. So there are 5 valence electrons. And then now you look at oxygen and decides how many valence electrons there are. So there are 2 oxygens, so that will be 2 multiplied by 6 equals to 12 valence electrons. If you try to sum up 5 and 12, you end up with 17. 17 is an odd number. Yeah. So as you know, no matter how you try very hard to arrange odd number of electrons around, in this case 3 atoms, right, you will never end up with an even distribution. So inevitably one of the atom will have an odd number of electrons. Yeah, so this is the way to sort of check whether you will have odd number of electrons or not. Yeah, so like what I mentioned over the lecture exercise, so from here what you need to do is just to arrange them. So I'll put N in the middle, then oxygen. Yeah, so because oxygen is the atom right at the end of the molecule, the simplest way is to allow it to have the octet configuration. So that will be forming a double bond. So because oxygen has 6, so in order to form a double bond, I will need to have 2 more. So in this case, 2 from nitrogen. Yeah. Then one of the common mistakes students make over here is they follow suit for the other oxygen. So what they do is I just put a dots like this, and then cross, and then after that they realize that I miss out 1 electrons for nitrogen, and then they will put it like that, and then they submit their piece of work. Yeah, and then of course when the piece of work is returned to the students, the teacher will mark it wrong because there's a total of 9 electrons around the nitrogen center. So this is not possible because nitrogen is in period 2, so cannot have octet expansion. Yeah, so because this is not possible, we need to do a bit of rearrangement. Actually, it's just a very simple rearrangement. You'll notice that between the N and the O, you can actually allow the O to have the octet configuration by simply removing this. Okay, so if I remove this and I just put the 2 crosses here, then the oxygen will have the octet configuration, and nitrogen will not exceed the octet requirement. So in this case, nitrogen will have 7 electrons around it, and this is perfectly fine because in all cases where given a choice, or when there's no choice, then nitrogen will have 7 electrons around it. Yeah, so NO2 end up with this particular dot and cross diagram. I mean, this is the common answer that you will have to submit for assessment purposes. Yeah, and then a little bit of revision. If I want to translate this to the Lewis structure, so it will look like this: N double bond O, and then dative covalent bond O, and then the central atom. Remember that you need to input the number of electrons around it, whether is it electron pairs or what. Yeah, and then I also did mention that in to help you in electronic bookkeeping, it will be good for you to input the number of electrons around the atoms right at the end as well. Yeah, oops, I think I drew a little bit too much. Yeah, right at the end as well. But if you don't wish to do that, that is perfectly fine. Yeah, and then those of you who followed what I did during tutorials, so I taught you formal charge. So if you do remember formal charge, then you know that with a dative covalent bond going from nitrogen to oxygen, nitrogen will take on a positive formal charge. So if you choose to write out formal charge, then just make sure that you don't draw out the dative covalent bonds, and then you put the plus and minus at the appropriate position. Yeah, so this is for NO2 lah. So we haven't quite answered the question in full yet. Okay, so over here the question requires you to do NO2 plus, and then I'm just going to use the same diagram over here, the one in red. Okay, so remember that the one in red, right, earlier on is being drawn like this, so crossed. Okay, and remember that when you add electrons to a molecular system, the excess electrons will go to the more electronegative elements. When you take out electrons, you take out from the less electronegative one. So in this case for NO2 plus, I will take out the electrons from nitrogen. Yeah, and this is perfect already because the nitrogen in the middle will have the octet configuration. So if you try to draw for NO2 plus, yeah, so this will be the answer. Yeah, so just remember to put the plus charge outside. Yeah, some of you might want to put the plus charge on the nitrogen. You could do that if you want, but it is perfectly fine to put the plus charge outside. Yeah, and for this question, you are just required to draw the dot and cross diagram. So Lewis structures are not required. So this is not required in your answer, but I just write it out for illustrative purposes. Okay, and then the next one I'm going to illustrate will be for azides. Okay, so for azides, really the simplest way is just to arrange them side by side. So N and then an N over here. All right, so what I need to do is really the easiest is to just try to form N2 dinitrogen first, because nitrogen has 5 valence electrons. Yeah, so 5 valence, so that's 5 times 3. Okay, that would be 15, but there's a minus charge here, so plus 1, so 16. So in that case, for azides, the number of electrons being distributed throughout all the 3N will be even. So there won't be an odd number of electrons. Yeah, so the simplest way for nitrogen to take on an octet configuration is to form a triple bond. So I'm just going to do just that. So just going to have dots, and then cross, and then cross. And then you'll notice that the 2 nitrogen on the left is more or less happy on their own because they already attained the octet configuration. So now I'm left with the nitrogen on the extreme right. And do take note that there's extra electrons. So that means that the N will take on a minus charge, and therefore it has the electronic configuration of oxygen, or valence electronic configuration of oxygen. So with 6 electrons, I'll just go around it with 6 electrons. Yeah, I will not attempt to put the electrons here, okay, because that will mean that the middle nitrogen will have more than 8 electrons in its outermost shell, and this is perfect already. So indeed there's a dative covalent bond in N3 minus. So this will be the answer that most of us will submit for exams. Yeah, so if you try to draw it out, nitrogen will be N, and then with a dative covalent bond to the end here, and then you put on a over or minus. Yeah, so if you do remember, it'll be good for you to indicate the lone pairs of electrons in order to help you in your electronic bookkeeping. Yep, and then if those of you who were around during the tutorial, I also mentioned that if you understand formal charge, you'll notice that this is actually not the best Lewis structure you can draw. Yeah, why is that the case? Because if you try to calculate formal charge, I'm going to calculate based on this. Formal charge is calculated based on a perfect covalent model. So if I do that, then I'm going to circle the nitrogen on the left hand side, and then I'm going to circle the middle nitrogen like this. Okay, and then I'm going to circle the one at the extreme right like this. So if I try to write out the formal charge, the one on the left will be 0 because originally 5 electrons. Now it still have 5, so 0 formal charge. The one in the middle will have a formal charge of +1. The one on the right hand side, extreme right, will have a formal charge of -2. So you notice that the formal charges are not distributed evenly between all the 3 nitrogen. So therefore, this particular Lewis structure is actually not the most favorable one. But of course, for H2 wise, because H2 you do not learn formal charge, yeah, so if you submit this is perfectly fine. Yeah, but if you really want to go a little bit more into the actual structure, you notice that a better dot and cross diagram for azide will look something like this. So I'm just going to draw it out. Hopefully it doesn't confuse anyone further. So just give me a while. Cross, dot, dot. Okay, like this. Just going to exchange the electrons, and then like this. Okay, yeah, so this will actually be the better version. Yeah, because if you draw it in this case, the formal charge is evenly distributed between all the 3 nitrogens. So you're going to have -1, +1, and -1. Yeah, so the Lewis structure will look like this. Okay, double one, dot, 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 dot. Yeah. Okay, if you are very confused at this stage, I think it is perfectly understandable. So you can just stick to, let's say, whatever we discuss over here. I think this will be perfect. We do not go into formal charge because normally the discussion of formal charge will continue by allowing the students to understand what is resonance structures, etc. But this is not in the H2 curriculum. Yeah, so if you are more interested, I will put a video link below where I attempt to explain oxidation state of formal charge calculations. Right, okay. Then for N2O4, I think it will be kind of straightforward already right now because you were told that it's a dimer of NO2. Yeah, so I think earlier on I have already shown you how to draw NO2 out. So it's based on this. Yeah, so you notice that the middle nitrogen has just 7 electrons around it. So when we say that it is a dimer, so that means that the 2 nitrogen should combine. Because when they combine, then the nitrogen will have an octet configuration. Yeah, so that will be the direction I'll be taking for N2O4. So if you are taking that direction, you can actually draw the answer. You can actually write out the answer quite easily. So I'm just going to do that right now. So dots, cross, and then cross, 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 and then dots, dots, oxygen, and then cross, 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 cross. And then yeah, this is the nitrogen over here. So I'm going to change to blue. Yeah, and then I'm going to have a dot here, then like this. Okay, and then I'm just going to repeat it on the left, on the right, and then now I'm going to repeat it on the left. Okay, so that will be oxygen. Yeah, so this will be the answer for N2O4. Yeah, so the hints are really just hit jackpots. Yeah, because you need to know how to draw NO2. Once you know how to draw NO2, you notice that the nitrogen is electron deficient because it is 1 electron short of the ideal octet configuration. So all I need to do is just to combine them together like what I've done above. Yeah. N2O5 is even sort of easier because they mentioned that it is a symmetrical molecule. So if you look at N2O4, where can I insert an oxygen so that I can make the structure symmetrical? Yeah, so if you look at it, you probably want to insert the oxygen somewhere here. Okay, so I just put the oxygen in. Okay, so maybe I should shift it down a bit more. Okay, so I'm going to put the oxygen in right here, oxygen. Okay, and then I put a dot here, cross here, and a cross here, and then cross, 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 cross. Yeah, so you can see that this is a symmetrical molecule. Yeah, so this will be the answer to N2O5. Okay, so remember that whenever we ask you to draw a dot and cross diagram, the first structure will always be easier, and then if we ever continue to ask you to draw something more complicated, it will be built on the previous structure. Yeah, but this is quite rare in JC2 because there are a lot more things to test the students in JC2, not just dot and cross diagram. Yeah, so do take note of that. Okay, you do not start from ground zero. Okay, so next dot and cross diagram to show the product from aluminum chloride and ammonia. So aluminum is in period 3, group 13, so it has 3 valence electrons. So with 3 valence electrons, the dot and cross diagram will be straightforward. It will look something like this. Okay, I think most of you, if not all of you, will be able to draw this out quite easily. Yeah, so remember that aluminum chloride is the exception. one of the few exceptions that you should be aware of, that is a covalent compound and not an ionic compound between metal and non-metal. In fact, there are a lot of metal, non-metal covalent compounds. Yeah, you'll notice that the aluminum center is what we call electron deficient. Why is it electron deficient? Because it is 2 electron shots from the ideal octet configuration. So it's electron deficient, so 2 electron shots from noble gas configuration. Yeah, so because it's 2 electron shots, let's try to take a look at ammonia. Ammonia will look something like this. Okay, so ammonia will have the dot and cross like this. H dot H cross dot H, and then nitrogen is in period 2, group 15. So 5 valence, so you have a lone pair on the nitrogen. So in this case, we say that the nitrogen center is what we call electron rich. This is electron rich. Yeah, because it can potentially donate its lone pair of electrons to an electron deficient site. Yeah, so an electron deficient site is also called a Lewis acidic site. Okay, so you might want to learn this term, Lewis acidic. An electron rich site, on the other hand, is also called Lewis basic site. So it's a Lewis basic site. Yeah, so if you learn all this term, I think it helps a lot. Yeah, so what's going to happen is they will combine. Okay, and like this. Okay, so I'm just going to draw. They will combine. Oops. Yeah, so they will combine like this. Just draw a little bit higher. Okay, I can't shift the thing properly without disturbing other things. Okay, so I'm just going to shift this up first. Okay, just shift it. Yeah, alright. Yeah, so that makes perfect sense. Okay, so Lewis basic site. Okay, yeah, so I think that should be fine. I hope you understand everything what's going on. This will be the Lewis structure. So this is known as an adduct. Okay, yep. If you want to show the Lewis structure, so it will look something like that: Al, Cl, 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 and then a dative covalent bond from nitrogen. Yeah. So if you like dative covalent bond, this is how you draw it. If you want to show formal charge, like what we discussed earlier on, then the formal charge will be something like this: N, H, 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 oops, H, and then minus plus. Okay, so remember that it's either you show dative covalent bonds or you show formal charges. You don't show both. Okay, when you show both in exam, it is incorrect. If you're unsure, then just show dative covalent bonds. Yep. Okay, next part B. Following compounds reacted to form similar products. Draw the structure formula. BeCl2 and ammonia. So again, beryllium is in period 2, group 2. So it has 2 valence electrons. So if it forms a covalent bond with chlorine, it will look something like this. So you notice that it is also electron deficient, but unlike aluminium, it has 4 electron shots of the ideal octet's configuration. Yeah, so what's going to happen is that it's going to combine with ammonia, not just 1 ammonia, but 2 ammonia. Okay, so I'm just going to draw them out like this. This is the dot and cross. Okay, cross cross, and then N cross dot H. Cross dot H, cross dot H. Okay, so like this. Yeah, you notice that the question did not ask you to draw a dot and cross. They just simply ask you to draw the structure formula. So if you don't want to draw the dot and cross, it's perfectly fine. You can just draw the structure formula directly. Okay, of course, that is provided that you are familiar with it. So BeCl, Cl, and then you can show the ammonia with the dative covalent bonds. Okay, so that's H, 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 and then the dative covalent bond, and H, H, H. Yeah, so this will be the answer that we are looking at. Okay, and then BF3 and sodium fluoride. So again, BF3 boron is in period 2, group 13. So it is same group as aluminium, so therefore it is 2 electron short of the ideal octet configuration. And sodium fluoride is an ionic compound, so it's like Na plus and F minus. So when both of them react, the fluoride will probably form a dative covalent bond with the boron center. Yeah, so if you want, you can draw the lone pairs of electrons in. Yeah, but do take note, do not draw the lone pairs here. Yeah, because the lone pairs is already part of the bonding electron pair that you represent with the dative bond. So it's incorrect. It is incorrect to draw the lone pair like this. Okay, so do take note of that. Sometimes during tutorial, we might purposely draw it out. It's really for illustrative purposes. Yeah, so in most cases, you do take note that we don't draw out the lone pair forming the dative covalent bond. Okay, so with that, this is the whole thing will take on a minus charge. And do remember to also incorporate the Na plus in. Yeah, because the Na plus is part of the final answer. Yeah, so remember that your final answer, right? They ask you to draw the products. So the products will be a product. It will not just be BF4 minus. So it has to be balanced by the sodium plus. Okay, so with that, we have come to the end of the review 2, class exercise 2.